Welcome to EDU World Space.
In this question, car A is moving to the north at a speed of 40 meters per second, accelerating at 4 meters per second square. Car B is moving at 30 meters per second in a direction which is 30 degrees from car A, from the vertical. And then it is moving at decreasing speed. The acceleration is 3 meters per second square, which is the tangential component. Then the radius of curvature of car B is 200 meters. And then in this question, we need to find the velocity and acceleration of B relative to A. So this is a relative motion problem. So first thing I find easy to do is to write down the velocities and accelerations of A and B in vector form. Okay, and then we can just use a definition of relative velocities and acceleration directly. Okay, so VA, start with velocity. So VA is 40 j hat meters per second. VB is 30 times negative sine 30 degrees I hat plus cosine 30 degrees j hat. And then this is just 15 times minus I hat plus root 3 j hat meters per second. Then we can find our velocity of v relative to a by definition is vb minus va. Okay, so we have minus 15 I hat plus 15 root 3 minus 40 j hat, and you calculate the components, you get negative 15 I hat plus 14 minus 14.0 j hat meters per second. Okay, so the magnitude of velocity of v relative to a is equal to 15 square plus 14.0 square. Okay, using Pythagoras theorem, and then you take the square root of the sum, get 20.5 meters per second, and then the angle or the direction is arctangent 14 divided by 15, you get 43.1 degrees. Okay, so the direction of the relative velocity is drawn in this way. Okay, pointing down to the left, EB relative to A, and then this angle is 43.1 degrees. Okay, so this is the magnitude of the relative velocity and the direction of the relative velocity. Okay, next we move on to the acceleration. So we are given that the acceleration of A is 4 j hat meters per second square. As for acceleration of B, okay, we know that the tangential component of AB is 3 meters per second square. So it's slowing down, so it's pointing in the horizontal down to the right. Okay, and the angle is 60 degrees because the angle from the vertical is 30 degrees. Okay, and then we have the normal component, which is 30 degrees from the horizontal, and then the normal component, it has a magnitude of 30 squared divided by 200. So basically it's VB squared divided by rho B, and this is equal to 4.5 meters per second squared. Okay, so based on the diagram, we can write down the acceleration of B in vector form. So this is 3 sine 30 degrees minus 4.5 cosine 30 degrees I hat minus 3 cosine 30 degrees plus 4.5 sine 30 degrees. Okay, so just note that sine 30 degrees is equal to cosine 60 degrees, and yeah, and so on. Okay, so AB, so we can calculate acceleration of B relative to A in vector form. You calculate this, you get, so by definition is AB minus AA, and you use your calculator, you get negative 2.40 I hat minus 8.85 J hat, okay, meters per second square. So we can find the magnitude. Okay, you just sum the square of the components, and then you take the square root of the sum using Pythagoras theorem. You get 9.17 meters per second square, and then the direction of the relative acceleration is arctangent of the y component divided by the x component, so you get 74.8 degrees. Okay, so to visualize the relative acceleration, so this is how it is pointing, and then this angle is 74.8 degrees. Okay, so this is the magnitude of the relative acceleration and the direction from the horizontal. Okay, and that's all for this question.